First of all, let me thank the Adoc Secretary for giving me this opportunity to come here and present this before you. And who am I? Like you see, in India, we have a lot of festivals, and every festival, there will be one essential ingredient. You will find somebody selling toys at the festival venue, and here I am the one to do that. So, I work at Inter University Accelerator Center. That is a research facility with a particle accelerator that is shared by all Indian universities. And this was supposed to be presented by another person, that is George Kasnadar from France. So that's why you see both the names. So the presentation is done by both. I mean, the transparencies were made by both. So first, let me talk about the free and open source software, because I believe in that. So the free software means freedom, not the cost, because you can sell free software. But what it gives you is the freedom. You get the source code, you can change the source code in the way which you want. And once you are in that world, nobody will call you a pirate. So you own your source code. And why I like it is, it follows the culture of science. It's a free sharing of knowledge, whatever you have. So it's a happy thing to do. And the present scenario, we have a lot of things and almost everything we need, like a browser and a very powerful operating system and office food and like a gym and Drupal, Moodle. And there are very good programming languages, everything in this domain, free or open source. But only one thing I find it is lacking, that is something for doing or teaching science. And that is what I'll be talking about. And before that, I'll just mention about one big free software or the open source experiment which is conducted. You can see this part of India. Actually, I belong to this place here. And here, the state government decided to use free software to teach high school students, that means 8th, 9th and 10th. Around 3,000 schools are there and 500,000 students per year. So it was a large project totally running on free and open source software. I was indirectly involved in this exercise, and this is going very well, and this is our former president. He is also a proponent of open source software. So this is one, so this project is called IT at School. So if you search Google for IT at School, you can get all the. So now the students themselves are generating content. So that is just one example, there are so many. And science, normally almost all countries it is taught in the conventional way. You have the blackboard, the textbook. But science has two parts, that is the theory and the experiment. And both are equally important. And also the technology part. Like all of us use a cell phone, but very few understand how it works, even in a preliminary, very rudimentary terms. So it is also essential to expose to the students how the gadgets works, because using a cell phone is one thing, but understanding how it works, at least superficially, is another thing. So we should have some simple device which you throw to the students at an earlier age, they play with that, and that makes a big difference. So exposing students to the technology in a proper way. So this, whatever gadget I'm going to talk about, so it can be used for learning by inquiry. A simple example is, in our schools they teach there is two types of current, the direct current and the AC, what you get in our mains power. From a battery you get DC, and from our mains power is AC. But very little is conveyed to the student, but if you can show that how it works, and that makes a better impact. So that's one example of learning by inquiry. So they do their experiments and try to understand what is happening. Another thing is, if you look at the PC, this is the most underutilized device in the planet probably. We use the PC to substitute a typewriter or a television or a tape recorder or something. But we don't really fully utilize the potential of the PC. So in this area, like the computer interface science experiments, there are very few companies. One is a major called Pasco, then there is a German called FIVI and Vernier. So 3-4 companies are there, and this is from Pasco. But the systems they sell, you can see here there is a box and there is a graph here, they are making some measurements. And at the moment, their starting cost is around $2,000 US, all this stuff, what these companies sell. So that's affordable to only a minute fraction of the world's student population, especially in US and Europe. These things are there. And India, a couple of labs have it, or IITs, but it's not really affordable to most of our students. So this is another kind of digital divide. If you look at it, say 20 years back when the computers started going to the school, and we did not know really how they will be used. But then at least one smart company pushed the product called MS Office, and all the students started doing some PowerPoint presentation and typing some Word document or a spreadsheet, and it became a big market. So suppose if we think that teaching science using this computer, if it picks up, maybe later it may be a big market, I don't know. But one has to explore. And when that happens, if you don't take any action to make some low-cost substitute, and only these sort of solutions will be available, and that will put a large number of students on the other side. They will not be able to afford them. So we have to have some solution that is affordable to all. So this PHINIX, it's an acronym for Physics with Homemade Equipment and Innovative Experiments. So it's all homemade stuff, just up something. So this project is a small step in this direction. That means make the computer interface experiments affordable to all students. And this is a technical aspect. Any laboratory equipment, like even if you take a thermometer, normally it has the sensor element, data processing, and a user interaction display. So this conventional model can be replaced with a computer. So computer will take care of the data processing as well as the user interaction, everything. All we need to do is, if you want a thermometer, you get a temperature sensor, somehow connect it to the computer. So that's an interface. So all we need is a sort of interface to have a lab equipment. Okay, this is the beginning of, so this is our institute, and this tall tower contains a particle accelerator. And my connection with this free software world started with our own application, writing a control system for a particle accelerator. That running the machine is about controlling around 1,000 signals, and it runs round the clock 365 days. And I found this system, Linux, the reliability is extremely high. So once I wrote the system around in 97 and put it there, it doesn't keep me busy because of occasional hanging or any event. So the extreme reliability gave me a lot of free time. Then we did other free software projects. And if you look at it, any major research laboratory, computers are used for doing experiments and analyzing the results. And these skills are needed for the industry also. So we are trying this PHINIX to extend the same to schools at a smaller scale with a smaller amount of money. So this was the initial version. You can see a big bulky box here, and it is showing a waveform. We call it as an oscilloscope. I mean, a time varying voltage, if you want to see how it changes with time, this will do that. And later on, when for the small one, you can see here there on the screen also, there's a waveform is displayed here. And this is connected to the USB, and one square wave is connected by this wire to this one. So you can call it as an inexpensive gateway to the PC. You feed the signals, voltages to this, and using software, you can process it. And you design the experiments. And to develop any experiments, the next thing is the sensors. So again, cost is a consideration. But the consumer electronics industry, yes, there is an explosion and a lot of things available extremely cheap. Suppose if you want to design an experiment to teach sound or measure the velocity of sound, all I need is a loudspeaker and a microphone that costs something like in India it costs 10 cents. It's 50 rupees, 5 rupees I can get a microphone and 5 rupees a loudspeaker. And with these two and the box, I can hook up an experiment that will measure the velocity of sound or reflection of sound. Many things can be taught. So it's similarly, if you want to do experiment with the light, there are phototransistors, thermistors, and DC motors, and all these things have become extremely cheap because of the consumer electronics industry.